Okay, let's get into this. We're doing a deep dive on a pretty specific piece of hardware today. It's the NTI ST-C5VRS-L-1000SP.
Which is a high-res VGO transmitter.
Exactly. And our mission really is to figure out one thing. How on earth does this little box push a KVM signal, your keyboard, video, and mouse over a quarter of a mile on just a standard network cable?
It sounds a bit like witchcraft, doesn't it? I mean, analog video VGA especially, it just degrades so fast over distance.
It really does.
But that's the hook here for you. The key takeaway is that distance, 1,000 feet. That's 305 meters, all using cheap, everyday CT5 or CT6 cable.
Wait, hang on, 1,000 feet. That's an extreme distance for any analog signal, let alone maintaining real-time access to a PC.
That's the core value. And if you look at the specs, it's all designed for that. It uses standard straight-through TIA E568B wiring.
And it's not just for, old legacy machines, right?
Not at all. The source material is really clear about the multi-platform support. We're talking Windows 10, modern servers, Linux, even MBOS.
Okay, but there's always a trade-off. The physics don't just go away. If you're pushing a signal that far, what happens to the resolution? The spec sheet promises up to 2048 by 1536.
Right, and that's an important question. So at that maximum distance, that 1,000 feet, you can still get a very sharp 1920 by 1200 resolution.
Which is already pretty impressive on its own, running over UTP.
Absolutely.
But what if I need that peak resolution, that 2048 by 1536? How much closer do I have to be?
Significantly closer, yeah. To hit that top-end resolution at 60 hertz, you need to pull it back to 600 feet on UTP cable.
Okay, so a bit more than half the distance.
And here's the interesting part. If you use shielded twisted pair or STP cable, thinking you'll be better.
You'd think the shielding would help.
Right. But for that top resolution, it actually cuts the distance down to just 400 feet. The spec sheet is very honest about that battle against signal decay.
So if the cable itself is the bottleneck, how does this thing actually manage the signal? How does it stop the video from turning into, a fuzzy rainbow over that kind of run?
And that's the aha moment. The real secret is the internal signal compensation.
So it's cleaning up the signal inside the box.
Exactly. The old way to do this involved manually setting all these little dip switches based on the exact length of your cable run. It took hours. This device does it all automatically. It adjusts video quality, and it corrects for something called color skew.
Okay, explain color skew for us.
It's pretty simple, really. The red, green, and blue signals that make up the video image, they all travel at slightly different speeds over a long copper wire.
Ah, so they arrive out of sync.
Precisely. You get these fuzzy colored edges on everything. This device compensates for that for a maximum delay of 62 nanoseconds.
Wow.
And it adjusts it in these tiny 2-nanosecond steps. So it basically just delays the faster color signals to let the slowest one catch up, and the picture becomes perfect again.
That automation is the genius here. It makes this otherwise complex problem totally plug and play.
It does. And the box itself is, what you'd expect. A rugged steel case, uses standard VGA and PS2 connectors, and only sips about 10 watts of power.
And I saw it has a few other features, too.
Yeah, some optional but really useful things. RS232 control, DDC2B support so the monitor and PC can talk properly.
And surge protection.
Which is essential, absolutely essential if you're running cables that might go between different parts of a building or even between buildings.
So to sort of wrap up the value here, you're getting high-resolution, long-distance console management using commodity cable that you already have. And it's all made possible by this really advanced automatic signal compensation.
And it's accessible. I mean, the transmitter is priced reasonably. It has a 2-year warranty, and they even offer a free trial. This isn't just theory. It's a real deployable solution.
Right. So that brings us to our final provocative thought for you to chew on. This device is brilliant at solving the distance problem for the user, the person at the keyboard. But it doesn't solve the problem for the computer. This extender is rated to work from, 32 to 122 degrees Fahrenheit?
Right, a pretty wide range.
But the server you're controlling from 1,000 feet away, it still needs to be in a very specific, environmentally controlled room. So the question is, how does extending the console this far actually change the logistics and the environmental planning for the host machine itself? Especially in, say, an industrial setting, something to think about.